All right, let's continue. This set of problems is pretty long. But anyway, let's go ahead and finish this up. All right, so now we're being asked some questions that require a lot of critical thinking. All right, so let's see here. So, which of the rational functions given below has the following feature? For an x-intercept, that means it's got to cross the x-axis over here at 3. You know that the numerator has to have a factor corresponding to x equals 3, which would be x minus 3 is the factor that would produce that root or 0. Okay, so that means it has to be C. All right, for the y-intercept to be 4, that means the point 0,4 has to be on the function. So when I plug in a 0, I should get a 4 left. If I plug in a 0 here, I would get a -2. Plug in a 0 for the x there, I would get a -4. Plug in a 0 for the x there, I would get a +4. So it's actually got to be C. All right. Horizontal asymptote at y equal 2. So that means at y equal 2, function has to approach that horizontal line. So that means you have to have x to some power on top and bottom. They have to be the same. And then the leading coefficient has to have a ratio of 2 to 1. Okay, so not the same degree top and bottom. Not the same degree. These have the same degree. They're both 1, but you don't have that coefficient of 2. Has to be this guy. All right. For the vertical asymptote to be x equals 2, you know you have to have a factor of x minus 2 in the denominator. That's this guy. All right. To have a whole, you have to have a factor of x minus 3 in the denominator, but you have to have one in the numerator too, so that they'll cancel out. So not that, not that. Has to be this guy. So that's D. Okay, horizontal asymptote right here at the x-axis. Right on the x, oh, it's a terrible picture. Let me try that again. Okay, so we know we got, here's the coordinate plane. We know we have a horizontal asymptote right here at the x-axis. Okay, so the degree has to be bigger on the bottom. So x to something, this has to be bigger number. Okay, so they can't be the same. So you have to have a degree bigger on the bottom. So that would be the only one that has the degree bigger on the bottom. Let me go back to the worksheet. All right. Snip this one. All right. So this is kind of fun. I like these. X-intercept 3 and 4. So you'd have x minus 3 and x minus 4 would have to be in the numerator on top. Okay. All right, to have a vertical asymptote at x equal 1, I know that I would have to have an x minus 1 in the denominator. Okay. All right, I need to have a horizontal asymptote at y equal 1, so that means I need the degree to be the same on the top and bottom. So I have 2 x's there. I need this to have 2. So I'll square that, and that'll be like 1 over 1 gives me the vertical asymptote. And then let's double check the y-intercept. If I put in a 0, I'd get 12 on top and 1 on the bottom, so that would fit. So that's what I'm looking for. There it is. Okay, let's try another one. X-intercepts are what caused the numerator to be 0. And so an x-intercept of -3 would be x correspond to a factor of x plus 3, factor of x minus 1. The vertical asymptote being x equal 4 means you're going to have an x minus 4 in the denominator. You need the horizontal asymptote to be 1. So again, this would have to be squared. And then let's see if the y-intercept works out. 0 on top, in for x would make it a -3 on top and a 16 on the bottom. So that would check. And that is +3 and -1. This guy right here. 38 should be C. All right, so you get the idea? X-intercept of 5 would be the factor x minus 5. X-intercept of -1 would come from the factor x plus 1. They'd be on top. Vertical asymptote, x minus 0, which would be x, and x plus 3. The degree would be the same. 2x's on top, 2 on the bottom, so that's all we need. And you'd have the horizontal asymptote being 1. Okay, so it's C. Okay, and let's see. 40. X-intercept, so that's on top. Vertical asymptotes give you an x minus 4 and an x minus 1 on the bottom. Horizontal asymptote being 1 means you got to have the same degree and the leading coefficient's 1. So I think it's just going to be that, which is this guy, which is D. And then you can plug in 0 for x and confirm that you get -3/2. Okay. All right, and then we're almost done. We have a few problems where we're being asked to actually graph these ourselves. So let's go ahead and kind of work through some of those. So I would probably do this. First, I would say x equals 0 is a vertical asymptote. So that's this right here. I know that. Okay, the degree on top, that's the vertical asymptote. The degree on the top and bottom is the same. So it's going to have a horizontal asymptote equal to what the leading ratio of the leading coefficients. So y equals 4/1, or y equal 4. So up here at 4, it's going to have a horizontal asymptote. Okay. All right, then after that, you can plot some points and kind of see how it's going to look. But it's going to wind up being the basic rational function look. But when you plot some points and take a look at it, it's going to look something like this. And one of the things I would find is what is called the 0 of the function, which is when the numerator equals 0. And so notice that would be an x of -1/4. So it's going to cross really close right here. Okay. And then be over here. Okay. All right. Let's try 42. I'd like that denominator factored. It's much easier. Then I can see I'm going to have a vertical asymptote at 4. So right here at 4, +4, and over here at -3 are going to be my vertical asymptotes. The x squared tells me it's going to, that would be 0 when x is 0, so it's going to cross right there at 0. I know that. The degree is the same on top and bottom, and I can see the ratio of the leading coefficients is 1, so that means it's going to have a horizontal asymptote right here at 1. Okay. All right, and then for the rest of this, it's hard sometimes to see how these should look. I sometimes will just plot some points and maybe pick something over here to the left of -3. Maybe this I kind of can tell what it might do. It looks like it's going to do something like this, But you can plot a few points to see where the pieces are. But once you start seeing them, you kind of get the gist of what they should do. Then you just find out, well, where are they going to be? Is this going to be up here, or is it going to be down there? And you just plot a point or two to figure that out. Okay. All right, let's go ahead and look at the last page. Is took way longer than I expected. Okay, so on this one, I would factor the numerator, be x minus 3, x plus 2. All right, that would equal 0 when, implies that it's going to equal 0 when x equals 3 or x equals negative 2. So that's going to be where it's going to cross negative 2 and 3. That's where it's going to cross the x-axis. The denominator would equal 0 when x equals negative 4. So that's going to wind up being a 1, 2, 3, 4, a vertical asymptote. Okay. All right, the degree on top is 1 more than the degree on the bottom. So I'm going to have a slant asymptote, and I can find the slant asymptote by using synthetic division or long division. Just make sure you put negative 4 in the box. If x plus 4 is your factor, negative 4 goes in the box. So this would be a 1, negative 4, add those, I'd get a negative 5. Multiply, and I'd get 20. Add those, and I'd get a 14. So this original problem that I had, okay, I'm going to move this over. Okay, if I divide is equal to x minus 5 plus 14 over x plus 4. And this helps me to see the slant asymptote. So I'm going to have a slant asymptote at y equals x minus 5. So here would be the, y-intercept at negative 5, and then it's going to have a positive slope of 1. So it's, the slant asymptote is going to look something like that. Okay. And it looks like then what's going to happen is I'm going to have a point that, or something that goes there and then back around. And it's approaching. I shouldn't draw it that way. It's got to cross at negative 2 and 3, and then it's got to get close to that slant asymptote. So it's going to do something like that. And then you'll have a piece over here as well. Okay. All right, let's look at 44. Okay, y equal 5 is the horizontal asymptote because the degree is the same and you got 5 out in front. X equals 3 is the vertical asymptote over here. 1, 2, 3, 4, 5. Okay, so it's going to do something like that. It's going to cross the x-axis where 5x plus 1 equals 0. So go through that and you'll get a negative 1/5. So just slightly over there it's going to cross. And that gives you a good sense then of what's happening on 44. It's going to come in and do something like this, where it crosses right there and then continues, and then the other piece will be somewhere up here. And you can plot a point, go out there and plot something like 5 and see where you wind up. Okay, let's look at one more. All right, this one might be good to think about the x and the denominator, factoring out the x and seeing the x minus 3. Okay. All right, so this is kind of fun. This one's going to have a horizontal asymptote. The degree on the bottom, see how it's bigger? So it's going to be at y equals 0. Okay, the vertical asymptote happens when you have a problem in the denominator that can't be fixed. So x equals 3. You're going to have a hole when x equals 0. Okay, so you should have a little hole at x equals 0. Now where that hole happens can be found, like I can get the y coordinate by plugging in 0 for the x. Okay, I can't plug it into the original. I have to plug it into when I got the x factor canceled out. So if I plug in a 0, I see that the y would be negative 1/3. So right here at 0, negative 1/3, I'm going to have a hole. Okay, I'm going to have a vertical asymptote at x equals 3. A horizontal asymptote right here at the x-axis. And so it's going to have to come in and hit that hole. So it's going to do something like this, I'm thinking. And then the other piece up here somewhere. Okay. And you can pinpoint it better by just plotting a point or two. All right, so that's stopping that.